Cool. So, hello everybody. My name's Ryan, and today I'm going to be giving a presentation trying to persuade you to use a programmatic approach when creating technical documents. So, a bit of background on myself. I'm one of the newest members of the Dairy NZ economics team, and I'm qualified in both economics and computer science. I've been employed at Dairy NZ for coming up 3 months now. And the first project that I was involved in was the Economic Farm Survey. So the Economic Farm Survey has undergone some big technical changes this year. It's made its debut as an online HTML document, and this is the primary form of distribution for the Economic Farm Survey. A vital part of making this online document possible was finding a process for easy management of the document. Websites tend to become quite cumbersome to manage when they grow in pages. In order to facilitate this online document, we used a programmatic approach to produce the document that allowed us to publish it with just a couple of clicks. So to explain exactly what a programmatic approach is, let's look at a traditional report production method. So you begin with some data that you extract from a data source, and then you pop that into Excel and you'll do some data analysis. Maybe you'll make some tables and some graphs, and then you'll copy and paste those into Word and then write some text around it. If you prefer not to torture yourself, you might use Microsoft Publisher instead. And then you'll send it to the cleaners or to the editor where you do some unwording or formatting, as it would be. In the programmatic approach, this process is largely integrated. So you still extract your data as before, but now the document building and the data analysis takes place in a joint step. The document is built around the data analysis. This means that all your work is in one area. Your data analysis is always at arm's length of the document you're building. Figures and values no longer have to be predetermined or pre-written. They can be determined by the code at the time of producing the document. And this is quite cool because it means that if you are changing data over years, you no longer have to write in the values each year. You can actually just refer to the value from the code. So to break it down even further, you have a whole bunch of different data sources that might be coming from databases, CSV files, Excel files. You then have a programming tool, and you'll see I put some logos of different programming tools on the slide, and I'll come back to that a little bit later. But you take your programming tool and you load that data into the memory. So that might be in the form of a data table or a data frame. You then use your programming tool to do some cleaning, some analysis, and some visualization, and then you get some outputs that you put into your document processing tool. And on the slide, you can see I've got Markdown and R Markdown there, which I'll have to explain a little bit shortly. So in the Economic Farm Survey, we leaned on R programming as our programming tool, and then we used Markdown. So the Markdown language is basically a tool designed to produce documents. It has the flexibility of HTML and LaTeX, but it's easier to read than HTML, and dare I say it, a lot less painful than LaTeX. And to elaborate a little bit further on why I put those programming icons there, so those programming icons there are Java, Python, and MATLAB, and those are just examples of 4 languages that can be used with Markdown. And one of the really cool things about Markdown is that you're not constrained to one programming language. You can actually use multiple different programming languages in one Markdown document. And that means that you're no longer constrained to using one programming tool. You know, if you're collaborating with someone else, someone can be using R, someone can be using Python, it doesn't matter. You can have them both in the document. So to take a specific example from the Economic Farm Survey, we have farm level data that we load into R. We then have a function that performs outlier removal. So we basically pass the data into this function and then it fires out a cleaned data set. We then pass this back to R to do some manipulation and create some different outputs. So examples of these might be owner-operated time series table, or a distribution of dairy operating profit. But the line doesn't even have to be that clear cut. So one example, or another example, is a regional weighted data frame. We use this data frame to create national level averages. And I'll just bring it up. We also put this table, I hope this is working right now. We put this table, that's not the right one, there we go. We put this table into the document as well. But this same table is the one that we use to create the national level data. So now, why would I say you should use R programming? Well, R programming is the preferred choice within the Dairy NZ economics team. When I turned up to Dairy NZ, I didn't use R. In fact, from my university years, I had concluded that R was a very counterintuitive tool. I've since changed my mind, and I think there are some really good reasons why you should consider R for doing your data science tasks. So as of yesterday, there were 16,174 packages available to use in R, and that's just on the official repository. That doesn't count all the packages available, like all the developmental ones you can download from GitHub. It's pretty hard to find a task that R can't do. It also has full Markdown integration, which gives it huge power, but you also have other tools like Shiny that allow you to do online app development. I know there's a few examples on MPI's website where they've used Shiny to create different tools. Shiny can seriously could make huge changes to data science, and I'm going to go off topic here. I'll keep going. So finally, R is open source and it has heaps of contributors, and it's free. So, you know, any profit maximizing company or individual can really get behind it. But I don't expect you just to take my word for it that R is a good choice. So here's an example from the Economic Farm Survey. So in the Economic Farm Survey, we have about 40 to 50 tables that we produce. I'm sorry, I didn't count them. There were too many to count. And this code on this slide is the code that we use to generate all those tables. And so it's 23 lines of code long, and it took about an hour to make. Once we had produced the code for the first table, we put that into a function, and bam, all the tables could be generated doing that. And so we used a package called GT to do this. GT allows for the fancy formatting that you can see in the tables, and let me just bring it up. Well, I've already shown you one, but I'll show you, this was my original example. We didn't write any of that in. That's all done by R. And so when you've got 7 of these tables, I'll just go right down to the bottom, just on one page, having a function that'll do it for you is a godsend to your sanity. To lean on another example, we also had a package that would generate our graphs. So R's Plotly package allowed us to implement graphs that are interactive. Users are able to download the plot. You can see the little camera icon up there that allows them to download as an image. They can zoom in on the plot. They can change the scale of the axes. And probably, I think the best feature is that if you hover on one of the points, you can also get a tooltip that can potentially convey extra information to the user. And so I've got a live sample here, and I think it's probably one of the better examples, is our New Zealand owner-operator herd size distributions. Now, if you just look at that graph without any interactivity, you just get the idea that roughly our distributions look similar. But we can add more value and transparency than that. If I hover over it, you can get a count of the number of data points that we had in the sample, and you can compare it to dairy stats. You can see there's a bit of a discrepancy there, but that's all part of adding value and transparency, because the thing is, that graph alone doesn't tell you anything about the counts. You can only get a percentage from that.
10 minutes.
Thank you. So a third example, which I'll briefly go over, is just outlier detection. So this is an example where you may not necessarily see it in the document, but it still adds a lot of value to the whole process. So as I bluntly pointed out on the slide, there is no real exact science to outlier detection, although that's not for the lack of people trying. Using a programmatic approach, we've been able to develop a consistent strategy to get rid of outliers out of the data. And consistency is key when you're producing a yearly document, or you're going to be producing documents where the same sort of data sample is going to be used. Because if you're not using the same process, then what you'll find is that your results begin to get driven by the sample selection rule rather than due to changes in the industry. And so by having a consistent strategy to remove outliers, we can actually add credibility to the work we're doing in the Economic Farm Survey. So I've told you why programming is useful, but the question that's really beckoning is why go to the trouble to join the document creating and the programming together? And I think there are 4 key components to producing a good data-centric publication. And it begins with accessibility. So talk about the dairy industry, or dairy talk as I've called it there, rarely occurs next to a bookcase. You know, the old hard copies aren't often there when we need them. Dairy talk does more often happen near a cell phone and the internet, and I would almost argue that it's very difficult to escape the reaches of the internet in this day and age. So HTML, the primary format that we've used, is a highly accessible format. Markdown uses a responsive HTML format that makes for easy viewing on cell phones, tablets, and computers. You know, whereas the likes of Word and PDF are software dependent, and they become increasingly difficult to read as your device gets smaller. The next reason would be repeatability. So repeatability is important because when you go back to do the next publication 9 months later, it's quite nice to not have to say, what did I do last time? By implementing it in programming and having it around the document, you don't have to ask that question because all the processes have already been written out and you've got them documented right in front of you. There is no ambiguousness. And I think just as important, and that's why I put it as bold on the slide, is that the wheel gets invented once. And that's important because if you're having to rebuild your document every year, you're not spending a lot of time improving the document. You're spending your whole time trying to recreate the document back to what it was the previous year. The third reason would be reproducibility. So reproducibility adds value and credibility to your work. It gives the readers the chance to test your claims. It allows them to explore your work, and they can even do their own data analysis. From our point of view, one thing that we did was to include a download button for all our data tables. Users can download all the tables and load them into Excel, and they can play around with the data. The only caveat to that is that you can't download farm level data because it's a privacy issue. And so what it means is that readers can reproduce essentially any part of our work except for the individual level stuff. And finally, the last reason is updatability. So a programmatic approach allows us to make changes to the document without impacting other sections. So say, for example, we had new data and we wanted to put that into some existing tables or graphs. We can go ahead, make the changes to the data in the programming and just press recompile. There's no changing the tables, there's no reformatting stuff, there's no changing the text about to shift it to make sure it all fits now. All we have to do is change the data source and press compile. And the other thing about using R Markdown is that we have a web version and a PDF version. They're both updated at the same time. We don't have to go to the website, make a bunch of changes, and go to the PDF and make a whole bunch more changes.
15.
All right. So in conclusion, we used a programmatic approach to produce the Economic Farm Survey. It allowed us to document all our processes in code, and we added further value by making interactivity possible. And now we can also spend more time in the future improving the document and less time building it. So I hope that the Economic Farm Survey has proved a worthy reason why you should consider a programmatic approach to your future technical reporting data science tasks. Thank you, and I'm happy to take some questions.